Okay, so here we're going to find this is the solutions for the study guide on Moodle. This is the part one of that study guide. We want to find the limit, like we want to find a graph that behaves like this. As you approach -1 from the left, its limit is 3. As you approach -1, which is an x value, from the right, its limit is 4. So you can just think of it from the left side of -1, that function is just going to, all that matters is that eventually it hovers at 3. Now, I'll make it a constant function 3 here. As you approach from the right, it's a constant function 4. That's just one possibility. Why you're saying, well, how do you know it's straight like that? Well, we don't. It could be something else. But this is what the equation would look like. It would look like a piecewise function. You'd have a little jump discontinuity at 1. Notice how your left limit and right limit don't agree. So it makes sense we'd be discontinuous. Here's I hate to use the word random, and I won't. But you might think, oh, that's a random function you're doing this time. It's just a bizarre one, right? All that matters is that I can make it curve as much as I want, but at 1, right, see, at -1, as I approach -1 to the left, it eventually has, like, its limit is 3. I can make it as wavy, as curvy as I want, but once it approaches -1 from the right, its limit is 4. That's it. And there are infinitely many possibilities that you could sketch here. For number 2, all right, we want to evaluate this limit. Always try this first. Remember, you can substitute where you want to evaluate your limit. You can almost find the function value as long as you don't get a 0 in your denominator. Here we don't have a 0 in our denominator. Makes me happy. So your limit is actually just equal to exactly how that function behaves there. So your limit's going to be 1/2. All right, for number 3, let's try doing that again. Let's just try plugging in 4 in place of x. So okay, the top comes out to 2 minus 2 is 0. The bottom 0, that's a problem. You can't have 0 in your denominator. So we have to actually do some work. So I'll remember that I cannot just substitute in 4 like I did for number 2. So I'm going to have to do some tricks here. When you have a square root, the trick is also always to multiply by the conjugate. Okay? So the conjugate of 2 minus root x is 2 plus root x. I'll multiply that by the top and the bottom, and you just distribute here. So if you remember the tricks for perfect square minus a perfect square, this comes out to 4 minus x. For the bottom, we're also to multiply those. But just in case you're wondering, wait, how'd you get 4 minus x? I'm just doing the, some of you call it FOIL method, but or the ETOF-TTOTS method, right? Each term of the first times each term of the second. But all it is a distributive property, and you see it's we get it's almost like a perfect square kind of deal. But we get 4 minus x in the top. When you do the bottom's not as easy to do in my head because it's not a term times its conjugate. But I'm actually not going to have to multiply those together. So it might not be as obvious when you see this for the first time, but look at those two terms right there. You got a 4 minus x and an x minus 4. Well, you can't cancel those. Oh, but factor out a -1, and you can sort of flip the order of the top. And so then they cancel out. Again, you might not spot that automatically. You might have tried to like multiply the x minus 4 to 2 plus x, but they do cancel out, and you just left with -1 over 2 plus root x. Now if we plug in 4, we don't have 0 in our denominator. It's just -1 over 2 plus 2, which is -1/4. That's our limit for number 3. So this is tricky right here to spot this, but eventually with enough practice you just kind of get used to those tricks. That happens a lot when you're doing the dealing with radicals and multiplying by the conjugate. Alright, and so for the next one, number 4, what we're going to do is I'm going to solve this two ways. I'm going to solve it analytically. I'm going to show how to kind of picture it graphically, but it's not necessarily as helpful. It is good to know that the domain of this function is between -2 and 2, but we're approaching the x value 2 from the left. So you can do this with tables if you do it with your graphing calculator, but here's the idea. As we approach 2 from the left, like 2 is in the domain, so your limit, you're just approaching 2 from the left, so you could kind of substitute it in. It doesn't do any bad things to that function. So your function value and your limit are both the same thing. This is a really trivial example. Since your limit is equal to your function value, they're the same. But here's what that looks like graphically. Okay, so if you graph that, it might be easier for you to picture this. I'm going to zoom in a little bit. I happen to know that if my domain's from -2 to 2, I'm just going to go slightly a little bit to the left and right. And so I'm going to go like a little bit up and down there. So if I look at this thing right here, as you approach 2 from the left, you see how it's a continuous function, like I'm connected the whole time. So that's a pretty good argument for yes, if you're continuous the whole time. Tables, It's not as clear in this one particularly, even though I really like tables, but I'm going to set my tables to ask there. And I'm going to look at my function value at 1.9. It's, it's a pretty small number at, if I do 1.99, they get smaller and smaller and smaller, and I'm approaching 2 from the left, so that's why I'm doing, numbers that are close to 2. Here it actually rounds up, and that looks like it might be, the number looks a little off, but it's 6.3 times e to the negative 6, so it's a number really, 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 really close to 0. But you can see, like, the bigger I push the numbers, the smaller the function value is, and so the limit obviously approaches 0 graphically.
We'll be right back. We're going to eat some Jello pudding. Da.
These are things expressed in this video showing those numbers verbally, not necessarily affect those schools. Hard to tell us whether that's just administration, schools or anyone else. These are website at sscrypto.org.